Okay, so in this lesson, we're going to graduate from inequalities in one triangle to inequalities in two triangles. So we're going to compare the measures in triangles and solve real-life problems using something called the hinge theorem, which is what I'm going to talk about next. So the hinge theorem states that if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the side of the first is longer than the third side of the second. Okay? Sorry, the third side of the first is longer than the first side of the second. In the same way, if two sides of one triangle are congruent to two sides of another triangle, and the third side is longer, then the third angle is larger. So I know that's a long paragraph to read. Generally for a theorem, they're shorter. But for example one, I want to just talk about the hinge theorem. So it says, given that ST is congruent to PR, how does PST compare to SPR? Now, first of all, we're not done with the reflexive property. We can say that PS is congruent to PS. It's important that two sides are congruent. We're talking about the included angle. So PST, I'm going to highlight PST in green. This is angle PST. I'm going to do SPR in blue. This is SPR. Now when we look at this, the important part to understand is that we have two triangles. PT is greater than RS. PT is greater than RS. So that means PST, the measure of PST, is greater than the measure of SPR, because the segment that PST makes is longer than the segment that SPR makes. So since 24 is greater than 23, PST is greater than SPR. Okay? In the same way, we're going to look at example 2. KM is congruent to itself by that reflexive property. JKM, the angle JKM, is greater than the angle LKM, which makes JM longer than LM. So we're looking at the segment opposite from these angles. The larger angle makes the longer segment. The longer segment is made by a larger angle. So basically, it's like when you open a door. If I open a door just a crack, it creates a small segment between the opening and the end of the door. If I open the door wider, I have a wider angle. The distance from the opening of the door to the end of the door is greater. So to illustrate that, that's a door. This is the doorway. The yellow or the red will be the actual door. As I widen this angle, I lengthen this distance. That's what the hinge theorem is getting at. So for some guided practice, I'd like you to try 1 and 2, and you're basically just comparing them. Are they greater? Are they less than each other? Or are they equal to each other? Because it's possible for them to be equal if the measures are equal. So just take a minute to pause the video, work through these 2 examples. When you're ready to check your answers, resume the video, and we can move ahead. Okay, so part of this is knowing how to name an angle. QPR is opposite RQ. QPS is opposite SQ. And since QPR is larger, that makes RQ longer. In number 2, PR is congruent to PS. RQ is less than SQ, so that makes SQ longer, which means the angle that makes SQ is longer, while angle SPQ is forming segment SQ or side SQ. So that makes SPQ larger than RPQ. So understanding opposite. What side is opposite what angle? To finish this up, example 5 is a good one because it talks about talking about turning towards the north and degrees and all those things. So it says 2 groups of bikers leave the same camp heading in opposite directions. Each group travels 2 miles, then changes direction and travels 1.2 miles. So they're traveling the same distance, east, west, north, south. One group will travel further away than the other. So group A, and we're going to do this so A is going to be green, red will be group B. Okay, So group A, we're going to start with camp right here. My point, that's our camp, the black point. So group A starts east. So they go east first. And we said they travel 2 miles first. And they turn 45 degrees toward the north. So 45 degrees toward the north would be this direction. Which means if they kept going, this makes a 45-degree angle, okay? And they traveled 1.2 miles, 1.2 miles. So that's what I mean, turns toward the north, because they were going east, so they went northeast, okay? 45 degrees north would be going northeast. Group B, they start going straight west. The same distance, the same 2 miles, and they turn 30 degrees south. So they're going south. And maybe I should do that at a little more gradual angle. So that's 30 degrees. So that means 30 degrees southwest. And they still went the 1.2 miles. Okay? So they still went the 1.2 miles. So what we're going to do is we're going to determine who's further from the camp. So that means this is going to form a triangle. The blue is their distance from camp. The important part is to find these angles on the inside, because that's the angle that forms the blue segment. Everything else in these triangles is the same. So whichever angle is bigger that we find means that group traveled further away from camp, even though they drove the same amount of miles. One of them's further away. So to find this angle, 180 minus 45 is 135. 180 minus 30, that's going to be 150. So group B formed a bigger angle, which means group B is a further distance from camp. Group B is further away. The reason they're further away is because 150 degrees is greater than 135 degrees. So the group is further, because we talked about that hinge theorem. They're further away by that hinge theorem. They turned a little more gradually, which took them further away from the camp, even though they traveled the same distance. So understanding angles and navigation and things like that, I think it's interesting. Maybe not useful for all of you in the future, but I think it's still an interesting thing to learn about. So in the guided practice number 3, I do want you to draw. I do want you to work through this on your own, so pause the video, work through it. When you're ready, check your answer. You'll see kind of a pattern in these problems, but this is definitely a good quiz problem, so be prepared to have examples like this on the quiz.